going to finish this chapter with arithmetic sequences, and it might be the most difficult part of this chapter. They are also linear, and you definitely need a calculator today. I think I said that yesterday and you didn't, but you definitely need it today. So an arithmetic sequence is a sequence of numbers such that the difference is common between each term, called your common difference. So we're looking for a common difference, or D equals is what we say. So here we go. We are looking at this one, and you're increasing by 2. So there's a common difference of 2, positive 2. This one, the common difference is you're decreasing by 4. So this is adding or subtracting only. So add or subtract only. There's another kind that's called geometric sequences, but we're doing arithmetic sequences, adding or subtracting only. Maybe we should put this in a little cloud. All right, so let's determine whether these sequences are an arithmetic sequence. If it is, write yes. If not, say no. And then when it says explain if yes, that's when we put our D equals. So the difference between here and here is 8. So from here to here is 8. Is from here to here 8? It is. So my common difference is a positive 8. B, 2 to 4, we're adding 2. From 4 to 8, we're adding 4. So that's a no. That's not an arithmetic sequence. That's something else. Repeated addition or subtraction. So here, it looks like we're decreasing by 2, or are we increasing? We're actually increasing by 2 as we're going. Our numbers are getting larger as it's going this way. So if your numbers are getting larger going this way, you're adding. So this way, can you see this up here? Larger, adding. Going this way, I guess you're never really going that way. I guess if you're going this way and you're getting smaller, you're subtracting. There you go. All right, so this next one for D, let's move my paper up. So it looks like 6, so we're subtracting 3, subtracting 3, subtracting 3. So my common difference is subtracting 3. Let's go back to this one since I didn't finish it. My common difference is adding 2. So I can either put plus 2 or just 2. Either one are fine. Okay, so this time they're telling us that this is an arithmetic sequence. So let's figure out what you're doing. Are you getting bigger or smaller? You're getting smaller, so you're going to be subtracting something. So to get from here to here, I'm subtracting 3. And make sure it's the same, so you're right. So my common difference is equal negative 3. So from negative 17, I can punch that into my calculator. Negative 17, and I need the next 3 sequences. So I'm going to subtract 3, and I get negative 20. And then I subtract 3 again. And then I subtract 3 again. So this is my answer. On this next one, we're increasing to 5. Is we increasing by 5 each time? Yep, just to make sure. So my common difference is a positive 5. This is always good practice. So what is 73 plus 5? 78 plus 5, 83 plus 5, 88. And there's my final answer. On your assignment today, they're going to ask you for your common differences and either you're going to put D equals or a no. Here they're wanting the next, just the one term, not the next three, just the next one. So you'd put just either the -20 or the 78. Okay, so that's not tricky at all. This is where it gets tricky. This is where you're applying a formula to find that next term. And so a to the nth is just kind of like your f of x. You're saying I need the next term. This a1 is your first term in your sequence. First term in your sequence. You gotta understand these formulas. So your term position, whatever they say, like if they want the 10th position, then you would put a 10 here. Sometimes we don't know it. Sometimes we just need to fill this out. And then your D is your common difference. And on this one, you may have to distribute to get to what you need. So let's take a look. It says, write an equation for the nth term of each arithmetic sequence using the formula above. Then graph these first 5 terms of the sequence. Okay, so this is just number 1. So don't get that 1 confused. So a to the nth, this is just a to the nth, is equal to my first term in my sequence, which is 9, plus n, because I don't care about what sequence number. We're trying to find the nth term. Nth term. I want to say nth term. Let's add that up here. You can't see it. There it is. It's so bright in here. Okay. And so we're just using this formula. It says -1. And then what is my common difference? What are you doing each time? Increasing by 4. So I'm going to put a 4 here. And then I'm going to take that 4 and I'm going to distribute this to simplify this equation. So a to the nth is equal to 9 plus 4n, 4 times n, and 4 times -1, which is -4. Now I need to simplify this because I've got like terms here. A to the nth is equal to 4n. We always put our variable term first. 9 minus 4 is a positive 5. So this is the equation. Okay, you're going to have to do this, simplifying this to write that equation to find the nth term. To find nth term. Next, we're going to graph this, and you're thinking, I don't have 2 values here. What it is this is considered your first term, second term, third term, fourth term. And these become your ordered pairs. So it's 1, 9, 2, 13, 3, 17, and 4, 21. So let's graph those 4 terms. So 1, 9 would be about here, 2, 13, 3, 17, right underneath 20, 4, 21. And this should create a straight line-ish, and then we'll just connect those as such. And what this will do is you can make predictions, like I can say, well, if it was the 6th term, it's going to be about 31. So I can make predictions with this by following this line. I can look at 6 and see exactly where that hits. All right, let's try the next one. Again, you're substituting into that formula above. That stinking thing is so bright. Let's see if I can get this changed. I'm going to move this a little bit and see if I can get this to show. There I go. Get rid of that sunshine. Okay, so again, this is number 2. That's not part of the sequence. So here's my formula above. So a to the nth, we're finding the nth term, is equal to my first term, which is -5, plus n minus 1. And then what's my common difference here? Negatives are sometimes hard to understand, but between here and here is adding 3. And so if I think about this, -5 plus 3 would be this, -2 plus 3 would be this. So my common difference is adding 3. So I'm going to put this on the outside, and then I'm going to distribute that to simplify. A to the nth is equal to a -5, because that was my first term, plus 3n minus 3. So that's the distributing. And then I need to simplify that. What is -5 take away 3? Well, let's put our variable term first. And -5 take away 3 is -8. So here's my equation for any term. So if I wanted to know the 18th term, I would put an 18 here. Okay. If I wanted to graph this, these are first term, second term, third term, fourth term. And again, my ordered pairs would be 1, -5, 2, -2, 3, 1, and 4, 4. Let's graph those. 1, -5, so that's going to be right about here. 2, -2. 3, 1, so that's 2, so 1 would be here. 4, 4. And again, it's linear. It is a linear equation. And then we would draw a line. So if I would say what would be the 6th term, I could go up here and say, that's probably about 9. Or I could say, what's the 6th term, and then put that here. 6th term from graph, or 6th term here. So 3 times 6 minus 8. So 18 minus 8 equals 10. So that was closer to 10. I guess it's going up by 2's. All right? Questions on that? All right. Here's another option. So let's say really all you need for this is your common difference in your first value in your sequence. So you need your A1 and you need your D, your common difference. Those are the two things that you will always need. So here, what's my common difference? Increasing by 5. Okay, increasing by 5. What is my first term? 2. So let's substitute that stuff into the equation to get the nth term. So we would say A1, so a to the nth, is equal to my first term, which is 2, plus n minus 1 times 5. Distribute and simplify. A to the nth is equal to 2 plus 5n minus 5. Keep simplifying. 5n, 2 minus 5 is -3. So here's my equation for any nth term. Now find the 12th term. So I'm going to, sometimes they will put the 12 here so you know you're talking about the 12th term. And you're going to say 5 times 12, because that's the term, minus 3. And then here we can use our calculators. 5 times 12 minus 3. So the 12th term is 57. All right, if you have any questions, let me know. Please read the directions carefully. Look at your notes again. So you're substituting a lot into this formula. Depending on what you're looking for, You can either find this by graphing. Sometimes if it's to the 12th term, sometimes it's just as easy to use the equation.